Hello, today we're going to learn about Lewis structures. We saw a little bit of this in the previous video, however we didn't go into anything about it. So, Lewis structures help us visualize. We first need to talk about how are valence electrons determined. That is the group number of the element in question, its ones digit. So for something like boron, boron is in group 13, so this would be 3 valence electrons. We have some idea of element symbols like nitrogen, oxygen, and lithium. So if we were to think of electron dot notation for these, nitrogen is in group 15, so it would have 5 valence electrons. That's what we're showing here. And lithium is in group 1, so it only has 1 valence electron. So let's take a look at the electron dot notations given some of these examples here. So sodium is in group 1, so it has 1 valence electron. Magnesium group 2, so it has 2. Aluminum is in group 13, so it will have 3. You notice how I'm putting these separate. Silicon group 14, so it has 4. And that's because electrons are negatively charged. They want to be apart as opposed to together. Phosphorus is in group 15, so it has 5. Sulfur group 16, so it has 6. Chlorine group 17, so it has 7. And argon with a group 18 is going to have its 8. And we pair them up only when they need to, and we can have 4 sets of pairs. So with these, we can do quite a bit. Take a moment and copy down these 6 rules so you have to use them, so you have them to use at your convenience. Alright, so let's look at an example of something very familiar to all of us, H2O, water. So, determine the number and type of the atoms. There are 2 hydrogens, and we don't write a subscript, which is the numbers down here, if we only have 1. Total number of valence electrons. Well, 1 electron for hydrogen, and there's 2 of them, plus the 6 valence electrons for oxygen, giving me a total of 8. We want to make a skeletal structure with the least electronegative in the center. Carbon will go in the center if present, never hydrogen or halogen. So we have a hydrogen, so we have to have oxygen in the center with the hydrogens around it. It doesn't matter if it's on the top or the bottom. This is just showing what things are connected. Next, we need to add a unshared pairs to each nonmetal, because we need to first connect with single bonds. So this is a shared pair of electrons, Okay. Hydrogen only needs 2, so they make their 1 bond and are fine. Oxygen needs 8 total electrons in order to be stable. It currently has 4 shared, and so we're going to give it 4 unshared as well. Count the final number to make sure you use the right amount. So 2, 4, 6, 8. I have 8, so this one is good. We're going to go through some more complicated examples in the next videos. So stay tuned and come back and let me know if you have questions.